In this third video of our lecture series on special shear wall design using ETAPS program, we'll be discussing about the C&T method and the uniform reinforcing method of a shear wall design. If you look at our model and select the walls, say for example, I have selected the walls below the ground, and then go to the assigned bar sections, then we will have some options here. There are three options: simplified C&T, uniform reinforcing, and the general reinforcing. So simplified C&T method is actually applicable for single-legged walls like this one, okay, this and this. You can design such types of walls using the C&T method. However, for complex walls like this or compound walls, you cannot use a C&T method. Okay. Say for example, I'm assigning here a C&T, assigned by section simplified C&T. It is applied. Then I'm designing it. Then after the design, if you apply on pair demand cost ratio, it's not a check. So pair demand cost ratio will not be shown. We can see the pair long-term reinforcement. The output shows some reinforcement, but where you need to distribute this reinforcement is very unknown. You don't know where to distribute this reinforcement. For example, the output says there are one leg, but in reality there are actually more than one leg. There are probably four legs in that compound shear wall. Okay, so they have determined an edge length. Edge length means if I take you to this, edge length is not actually the boundary element all the time, but pretty much the boundary element. So they're saying that the edge length is 38 inches. It means that from this to this, say for example, up to this length, it is 38 inches. And in that 38 inches, they are providing a certain amount of reinforcement. Okay. The center of which, the provided reinforcement, the center of which will be at the center of this 38 inches length. Okay. So if we move back, in these 38 inches, you have to provide 13.29 or 14 inches reinforcement. So left top, right top. So let's not talk about the top. By top, they mean that the top of a wall. And by bottom, they mean the bottom of a wall. So reinforcement will be high at the bottom of the wall. So let's talk about the bottom. For the bottom, the edge length is 38 inches. They have actually started their trial and error using 38 inches actually, I guess. In that area, in that edge length, they require a rebar area of 21 inches. So let us do it in another way. Say, for example, this is, let me teach you, say that we are not designing a compound wall, okay? So if we are not designing a compound wall, then we are assigning a pier to it. Say it's pier 2, is pier 3, pier 4, say it's pier whatever 12. So after applying the pier levels separately to these wall segments, so this is only for the learning purpose. We will not design this wall using the C&T method. Rather, we will use the wall either using the uniform reinforcing method or the general pier section method. So after assigning different pier level, we can now design the wall under the C&T method. After the design completion, you can go there and have actual data which may be of importance or application to you. So they are giving you the edge length. So you can consider this edge length as your boundary length. However, at the edge, they are providing you the boundary element length. So at the bottom left and right, they require a boundary element length of 24 inches and the 70.7 inches. So this is lower than the edge length in which you have to provide this amount of reinforcement. By this, I mean that if this is your wall and you are designing the wall using the C&T method, then this pink part is your edge length for allocating, for distributing your flexural reinforcement. Say the amount of flexural reinforcement, the demand is 12.8 or 13 square inches. So you have to provide 13 square inches in this, length, 28 inches, 35 inches. So let's say that it is 28 inches. In it, you are going to provide 13 inches. So this line, so there are four lines. You can distribute it in your way. There's no problem in it. So that's one thing. And in there, how much of it you need to confine using hooks reinforcement? You can confine it completely, or you can comply, yeah, confine it up to this edge length under boundary element. I would suggest to you that you use hooks reinforcement up to this length, up to this edge length. Confine your total flexural reinforcement area. So if your wall is 101 inches long, look at it. You can find the length of your wall somewhere here. 103 inches long. And in it, you are consuming about 30 inches and 35 inches. Say both are 35 inches. 35, 70, you are left with 33 inches, which is the middle part. This, there you will provide only the distribution reinforcement. It means that the reinforcement provided here has no effect in bending capacity determination using C&T method. C&T method only considers the reinforcement provided in this edge zone. Okay, so this is the important thing that you should know from here. Again, if you look at this one, then you get a edge zone of this 28 inches, and you need to provide 11 inches of reinforcement in it. And there are some issues regarding the shear design. Shear design is not adequate, etc. So I hope C&T method is clear to you. But C&T method, we are not going to use the C&T method here. By using C&T method, you can have some idea how you can design your wall. For example, I prefer using the general pier section, which is a little tougher to model, but gives you a certain PMM ratio, demand capacity ratio, which you can easily understand that it is 80% or 90% or 70% demand capacity ratio. So my wall is safe. Okay, but here they give you a reinforcement. If you provide that or more than that, you are safe. That's what it means. But in practice, you may get some walls where you may not want to apply the C&T method. For example, you got this wall, and by C&T method, the model says that up to this length, it is 38 inches. You need to have 14 inches of reinforcement. But say that it is a wall I have designed. Now you are reviewing it, and you can say that you can say to me that the edge length should be 38 inches, and in it you must provide 14 inches of reinforcement, and 38 inches again here, and then you have a certain area left here. Then I may say to you that what about the reinforcement here? I can take the benefit of it also, right? So this can be covered by the uniform reinforcing method or the general bias section method. Uniform reinforcing method has some disadvantage, because uniform reinforcing means that you select the wall, you assign bias section uniform reinforcing, choose the material property 3.5 KSI. The rivet strength is actually taken in other design preference. Bar size is 20 mm. I am using 4 inches spacing. Clear cover is 2.5. Bar size is end or corner bar. End or corner bar means these bars are called the end or corner bars, and these are the distribution bars. They call them the same, I guess. Yeah, distributed bars, 20 mm. So let's say 20 mm, and those are not 20 mm, those are 12 mm. Okay. and the end or corner bars are 20 and reinforcement to be checked. Okay. Now I design these walls and I go to the buyer demand price ratio. The walls seem to fail, right? To 2.5, etc. So this is an issue. Uh, Here, actually, since it is a compound wall, we are not going to design individual segment of it using the uniform reinforcement method. Rather, we are going to assign the wall a single buyer level, which will be 1, and then we are going to design it, and then check the demand capacity ratio. Huh? Probably there is some mistake, or reinforcing is lost after assigning the new buyer section. Now the wall doesn't pass. It has a demand capacity ratio of 1.5. So what do you get from here? Now say if I assign the uniform reinforcing but make the distributed bar 20 and keep all other data as previous and then redesign it, then we get a demand capacity ratio of 76%. So what do you understand from it? What you understand from it is that this reinforcement is also very useful. If you have a good amount of reinforcement here, you can utilize it in your structural design of your wall. So you can use the uniform reinforcing method. But what if the wall reinforcement is not uniform? Say here in the edge zone, you have 20 reinforcing at the rate of 3 inches center to center. But after that, you have say 16 reinforcing at the rate of 6 inches center to center. This thing you cannot cover using the uniform reinforcement method. Also, you cannot cover that using the C&T method because you want to take the contribution of the middle reinforcement. C&T method does not take into account the middle reinforcement, so there's a total loss. Because if you do some assessment of existing buildings or if you review the structural design of another consultant, then you have to check it in a way so that you are not very conservative. C&T method is very conservative, and the uniform reinforcement method is not most of the times applicable. So you have to go to the general prior section method. So I hope C&T method and uniform reinforcement method has been made clear to you. I hope you can take decisions and design your walls considering these two methods. Also, I tried to give you some pros and cons of each method. You may say that whatever Shear design and other design, we'll go through those items in our future videos. Thank you for being with us.